Dear students, today we are going to discuss about problem number 7, projections of planes. In the problem it is given that it is isosceles triangle and base is 25 mm and altitude is 35 mm. So the given thing is plane, which is triangle. It's a isosceles triangle and base is 25 mm and altitude is 35 mm. In this problem, resting on HP or VP, it is not given, but something else is given, that it is having the front view. Front view is seen as 25 mm equilateral triangle. So when word front view comes, at that time it will be resting on VP. If it is top view, then it will be resting on HP problem. Then after that, it is given that it is resting on one of its side, which is perpendicular to VP. So that's why it is resting on side problem. And after that, angle with respect to HP is given, which is 45 degree, and edge parallel to VP is having 45 degree. Then at last, angle with respect to VP, it is not at all given, but something else is given. The third position is seen as a 25 mm equilateral triangle. So front view is 25 mm equilateral triangle. So that's why based upon this thing we have to find out angle with respect to VP. Based upon the given things, we are going to draw first diagram. In first diagram, XY line will be drawn, then after that VP, HP we are going to differentiate it, then after that we are going to draw the isosceles triangle. Here what we are going to do, first initially we will be drawing 25 mm line. As it is resting on HP, the 25 mm line base edge we are going to take it as resting edge. Once this 25 mm resting edge is done, then from the midpoint of this 25 mm line we are going to draw 35 mm line. This is midpoint of this A-B line. Then from this midpoint we are going to draw a line which is having 35 mm line, where we are going to get point C dash. Once we get C dash point, join A dash, C dash and C dash to B dash. Then we are going to get our isosceles triangle. Then once it is done, then draw vertical downward projection line to get top view or first top view. And first top view will be equivalent to the altitude of that isosceles triangle, which is 35 mm only. So A dash to C dash dimension will be 35 mm. Then draw projection lines from A dash, C dash and B dash to get equilateral triangle of 25 mm sides. How we are going to draw that? First we are going to draw A dash B dash line, which is having 25 mm, which is equivalent to this A dash B dash. Then after that, taking B as center and A dash as center, we are going to draw two arcs of 25 mm dimension, so that we are going to get C dash. Now we know that when any line, if we are giving inclination to that, it will be deformed, and one more thing, that it will be always reduced, it won't be increased. So here 25 mm cannot be increased, it will be remaining same. So that's why we have taken this 25 mm line as our reference line. But this 35 mm line, if it is given some inclination, A dash, B dash and C dash, this line, if it is given some inclination, this can be turned into 25 mm dimension. So for that, what we are going to do, we will be taking vertical downward projection line from C dash and also from A dash, B dash, we are going to draw vertical downward projection line, and taking this point as our new center, which is A dash and B dash, measuring this dimension, which is 35 mm, taking A dash and B dash as our new center, then we are going to draw one arc which is equivalent to 35 mm or dimension between A and C. A and C. Here also I should delete all these things. Dash as it is top view. Sorry for that mistake. Okay. Then after that, we are going to extend this projection line from C dash. Once it is done, wherever it is intersecting, here we are going to get our new C point and join this dimension. This also will be equivalent to 35 mm. Make it little bit thick. Now measure the angle with respect to this AC line with respect to XY line. Then we are going to get angle with respect to VP. Once this diagram is done, then we'll be moving to fifth diagram. In fifth diagram, it is given that it is having 45-degree angle. And what is having 45-degree angle? The line or the edge which is parallel to VP is having 45 degree with respect to XY line. And in the fifth diagram, the line which is having 45 degrees A dash to B dash line. Why A dash to B dash line? Because this line is having perpendicularity with respect to HP. When it is having perpendicularity with respect to HP, then obviously this line will be having parallelity with respect to VP. The only line which is having parallelity with respect to VP will be A dash B dash. Other lines will be having inclination with respect to VP. You can see that over here line AB is having parallelity. Okay, the line AB over here, it is having parallelity with respect to VP, whereas other lines A to C and A to B, they are having inclination with respect to XY line. Some angle with respect to VP, it is there. As A dash to B dash is having perpendicularity which is 90 degree with respect to HP, then always that line will be having 0 degree with respect to VP, and vice versa will be there. If a line is having perpendicularity with respect to VP, then it will be having parallelity with respect to HP. In this diagram, we are going to place A dash and B dash on this diagram. Then once it is done, then measure this B dash to C dash, which is 25 mm only. So draw 25 mm arc taking A dash as center and taking B dash as center. Draw another 25 mm arc. This point will be giving us C dash. So A dash is there, B dash is there, then join them. Final diagram, draw vertical downward projection line, draw horizontal downward projection line. We are going to get the sixth diagram.